Arrays are one of the most common ways to store data when writing software. Since we use the array data structure so frequently, it is critical that we understand exactly how they work and also the common space-time complexities associated with performing various tasks on the array. It is important to understand the basics of how memory works, as it is a topic that underpins arrays, so make sure to check out that video on memory before watching this video. So recall from the video about memory that when we declare variables, that we're storing these variables in these memory slots here. And each memory slot is a byte, where a byte is 8 bits. So we also talked about if the number is larger than a byte, how the operating system needs to find the next free number of memory slots required to store the number. And well, that's exactly how things work in static arrays too. So let's say that we have an array. Let's say we let A equal to the array 1, 2, 3. So in this situation here, we have the first element. So A of 0, and I'm not assigning this variable here. So rather than using equal, I'm just going to use this arrow here, because what I'm going to say is that the number 1 is equivalent, so I might do this double arrow here, to the number 0, 0, 0, 0, 0, 0, 0, 1. So when we say that A0, which is 1, is equal to the 8-bit number 1, and likewise we would have A of 1 and A of 2, and all of this is going to be the same, so I'm just going to do a dot 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 dot, and in this case we're going to have 1 0 at the end here. So I might put some more dots here, and then 1 1 at the end. So here we've got the number 2, so there's 0 1s and 1 2. Here we've got 1 2 and 1 1, which is the number 3. So basically the computer, it looks for the next 3 consecutive free memory slots to store the numbers A0, A1 and A2. So here we have just created a brand new program. So the first memory slot will be here. So we're going to say A0, and we know this is equal to 1. It will actually get stored in binary numbers. Then the second free memory slot here, the first element in the array, and then the second element, or the second index in the array, I should say. So in a static array, we allocate the needed numbers. So here we have 3 numbers, and we allocate those 3 numbers in the memory slots ahead of time. This means for our example here, we can either declare our array data type with the number of slots, or as we've done here, the number of slots is implied by the fact that our array has been initialized with these 3 numbers here. So if you're coming from a JavaScript background, you may be thinking, well, I make arrays all the time, and you don't need to declare how many elements are in an array, and you can freely add or remove elements as needed. And that's because in JavaScript, arrays are dynamic. In other languages such as Java, you have the array data type, which usually means the static array data type, and then you have lists or perhaps various types of lists, which refer to dynamic arrays. So let's consider our example here again, where we got a equal to 1, 2, 3. But this time, let's think of it as a dynamic array. So let's say, for instance, that our program, it already has some value of x stored in this fifth slot. So we need 3 consecutive slots. And we can see that we take the third and fourth index, which refers to the memory address. But then we have this blocker here. So if we're creating a static array, we would need to, the computer has ways to detect, okay, well, there's a slot here, we won't have enough here and here, so we'll go to 6, 7, 8. But with dynamic arrays, it's a little different. This time we don't need contiguous memory slots because we leverage a pointer to point to the next free memory slot. So as discussed in the video about memory, each memory slot has both a memory address and a potential value it can contain. So if you've used languages like C or C++ before, you may have seen the hexadecimal memory address. I think it's hexadecimal. It's a long mix of numbers and strings. So rather than this simplification here where we've got 3 as the memory address, you have some number where it's 0x3, 4, and then a bunch of numbers there, which refers to the memory slot, the memory address in your RAM. So, languages like C and C++, you can see the memory slot that your variable has been assigned to by just dereferencing your variable or figuring out what the pointer of your variable, the memory slot it's assigned to. Whereas in some of these higher level languages like JavaScript, this detail is hidden from us. We don't have this fine grain of control as it's handled internally by the language itself. This is good and bad. It's good in the sense that it removes complexity from us, but it's bad in the sense that the language is less performant in certain situations. But it's totally possible in lower level languages to assign a memory slot to the address of another memory slot, which is known as a pointer. So for our dynamic array here, now we're considering it as a dynamic array. Basically, we could have the first memory slot, and I'm just going to use the number 1 now to make things simpler here. And then what we could do is in this fourth memory slot, we recognize that we don't have enough room in the fifth memory slot, but we can actually assign the memory slot to the reference of 6. So basically, and this is where the name pointer comes from, this memory slot, rather than having 2 here, is going to point, and I might do this here like this. This points to the 6th index in the memory. So then you might have the number 2 here. And then it's possible that this isn't free, but here we can say, okay, well, we can have a pointer from the 7th index to the 8th index, let's say. Although if there was something in the 8th, we could skip anywhere. So let's just do an arrow here like this. So that points to the 8th memory slot. And then this will contain the number 3. So basically, in the case of a static array, which we've seen here, we declare the number of the elements that we want ahead of time. But how does the computer know how many memory slots this dynamic array needs? Well, dynamic arrays, they tend to allocate about twice the memory as needed. So in a dynamic array, where we've got let A equals to 1, 2, 3, this is sort of like when we initialize it, this is sort of like saying, okay, we have 1, 2, 3, but then we have the 4th, 5th, and 6th memory slots. You know, they're empty in anticipation that we'll need to add more. So we can already see that dynamic arrays, they take double the memory. So basically, it's allowed, or it's allocated 6 spots, which is twice the number as it needs, roughly. And as more elements get added, so in dynamic arrays, we can add more elements past the number that initially got initialized. As it reaches the later half of the array and gets closer to the end there, there's some inbuilt mechanisms that will continually double the size of the array. So basically you would need to have, well, in the case of a static array, you would need to have 6 contiguous blocks of memory for doubling the size of memory slots if you wanted to make your array into a dynamic array. But as you can see, the dynamic array, it consumes much more memory compared to the static array, or simply we'll just call it the array. But the dynamic array is much more flexible. So that's the trade-off. So let's take a look at the complexity of common array methods. So arrays are great if you need a quick lookup. So as you can see here, if we want to look up, you know, this element here with the value 2, we can simply go to the first element here and we can simply look that up. So what we can say is, well, lookup is O of 1 time complexity because it only requires 1 memory slot to be accessed. So we can say, and lookup, sometimes they call it search. So if you're searching for an element in an array, we know that that's O of 1. So let's think about, let's say we want to append a number. So we've got the number 3 here, or we've got the number, okay, so there's 2 different cases. Let's say we want to append a number here to the dynamic array. Well, there's a free memory slot here, but even if there wasn't, we could simply point to the next memory slot, and let's say we wanted to put the number 4 there, for instance. Well, we only need to allocate one, well, there's 2 bytes being allocated here, but in terms of complexity, space complexity, that's sort of O of 1. So since we only need to assign 1 byte, which means there's only 1 memory lookup, if we append to the end of the array, which in JavaScript is push, we can say that that's O of 1. So let's put a table here where the left column is the action and the right column is the complexity, and specifically the time complexity. So we're going to have a few of these. So let's just add a few lines here. And if we need more, we can just simply add more. But append, or let's just say push, in the context of JavaScript. And if you're in a different language, it's obviously the equivalent in that language. But pushing to the end is an O of 1 operation. And all of this becomes important because when we do our algorithms, when we're solving them, whenever we're using any of these methods, and as you can imagine, arrays are really popular, so we'll be using these methods like pushing to arrays and popping arrays all the time. Knowing the complexity is directly related to how fast your algorithm runs. So without understanding of this, you won't be able to determine how fast your algorithm is running and if you can do better or not. So that's why we're going into a bit of detail here. But then we're going to be able to apply all these in the next video, so we're going to start to do some Leet Code questions. So it's going to be super cool. But I found this really interesting as well, just learning it at a deeper level how memory works. And your everyday coding becomes more efficient because of it, or at least you have the awareness of how things are working under the hood. So that's cool. But so let's say in this case we've pushed the number to the end, but what happens if we want to splice a number? So what that means is, let's say we have the numbers 1, 2, 3 here. Splicing means we can add in another number. So it's also, you can just call it insert as well. But let's say I wanted to put the number 4 before the number 3 here. So in the simplest case, we could just shift this number here, right, and then where this 3 was, you could put a 4 there. But this is the best case scenario, and that's because of two reasons. One is because this is the second last example, the second last element in the array for this particular example. But then we're also assuming that we have free memory there next to it. But we need to consider the worst case scenario for big O notation, and that's all we care about. And that means that either we want to splice a number near or at the beginning of the array, or we need to take into consideration that, or we also need to take into consideration that we don't have enough memory slots to add in another number. So in either case, what we would need to do is we would need to take a copy of all the elements in the array. So let's say we're just on our static array here. We'd need to copy all of these elements here. The computer would have to look up the next spot where there's 4 free elements, so 9, 10, 11, 12. And then it has a copy of that. It puts A1 here, A2 here, A0 here, A1 here. Then we'd need to put in our 3 here. So we'll put in this number here, and then we'll need to move this over and shift it over a memory slot. That should be the 4 there, and then 3 will need to be shifted over. So essentially, as you can see, since we've needed to copy the whole array plus add in the new element, we can't guarantee that it's going to be at near the end there. We've got to consider the worst case there. So that means splicing is actually O of n. So splice is O of n, or that's inserting. Inserting an element is O of n. So this is also true for the unshift method. So I'm just going to put US for, in JavaScript you have unshift, and what that does is it basically splices the element at the very beginning. So if you want to put the 4 in front of the 1, obviously that's going to be the worst case scenario in the splice sense, but that's just what the unshift method does. So yes, once again, that's going to be O of n. The shift method, so shifting, that's basically where we remove the first element. So if we want to remove that, what will that be? So I'm just going to put here S as well. Now this one might be slightly surprising, but basically if this array has been initialized, so array A equals that, the first element is here, and it's been assigned to this address here. And that's why, if you mutate arrays in a function, it actually mutates the reference. It's passed by reference rather than passed by value. Oh, yeah. So there's a reference to this particular... sorry, is that the other way around? That might be the other way on. But basically, when you pass an array into a function, if you mutate that array, you're mutating the original array. Or if you perform an operation on the pass variable, it mutates the original array, and that's because it's pointing to this array here, and the array keeps track of each of the indexes. So basically, if you want to get rid of this 1 here, but the array is pointing to this bit in memory here, basically you can't just simply remove this, but you have to shift this over 1 and shift this over 1. So then that now represents the first spot in array. And because you need to assign each of the remaining elements rather than the first into the previous slot, it's essentially an O of n time complexity there. So splice, unshift, and shift, they're all O of n operations. And shift, it's sort of, as we saw, that we're shifting this across. So that's where the name from JavaScript comes from. Yeah, shifting it across. And then unshift is essentially, the reverse, where you, rather than shifting everything back, you got to move everything in the other way to make room for the new element at the beginning. So then in JavaScript they call it unshift. And having this awareness of the memory, it actually helps you remember all of these sort of JavaScript terms, because they're based on what's actually happening. So if you're just familiar with JavaScript, well, chances are by now you probably memorize a lot of these core methods that you use, but it's kind of helpful that it's in the name, that it helps you determine what's going on. And then you also get the understanding of the time complexity associated with that. So that leads us to think about, okay, well, what if we want to get rid of this element? So in JavaScript, if we want to delete the last element, that's known as a pop. We're popping the last one. So if you delete the last element, we only have to free up this memory slot. So we access that memory address, and then we can remove that. We can free it up. We don't have to do any shifting of the other elements in the array. So because of that, this is an O of 1 operation that can be done in constant time. But in comparison to something in the same way that splice is O of n, if we want to simply delete something, well, that's what splice is essentially. Oh, no, sorry. Splicing is adding something in. Slice. So there's splice and there's also slice. If you want to remove something. I just put del here for delete. Basically, this is going to be a similar thing. This is going to be O of n. Because if we want to delete, say, this element here, all of the remaining elements, they're going to need to shift over. And we need to consider the worst case that we delete the first element, which is essentially the same thing as shift, because everything will need to shift over. So that's O of n as well. And you might already see something here, which will help you when you're coding. That is basically when you choose an array, or if you are choosing an array, a good way to know how to choose it is if you're looking for quick lookup, so which will have O of 1, constant time, or if you need to push something to the end of it, that's going to be constant time. But if you're doing stuff in the middle of the array, that's going to be linear time. So that still might be the best option you have, but there might be other ways to do that. For example, using an object. And likewise, if you just need to have the numbers, and then you might need to remove the last one. If you can structure your algorithm such that you're just removing the last element, that's going to be a constant time operation. Whereas if you need to constantly delete elements in various different places, especially at the start of the array, that's going to be an O of n operation each time. So you definitely want to set up your algorithm to prefer to make use of, well, basically when you select the data structure, you select the data structure in a way such that the operations that you, or the algorithm that you're trying to solve, the operations that are performed on the data structure that you've chosen are the most efficient in comparison to different data structures that you could choose. So that's the delete and pop comparison, a bit of a spiel on choosing a data structure. But of course, you're going to need to know more data structures to be able to choose between them. And they're quite interesting. They get more and more interesting, I think. So yeah, basically and another thing to note is like all of the higher order array methods on arrays. So things like your mapping through or for each or your filtering. I'm just going to put in H/O. I might put an arrow here because I usually use an arrow function there. These are typically O of n because you need to loop through every single number in the array. So anything where you're looping through the numbers in an array, or we're doing something, that's going to be O of n, assuming that there's nothing within the O of n operation that's going to set you off. For example, 2 for loops or another O of n within the O of n. So that's just something to keep in mind. But yeah, understanding of how memory works in arrays, it's absolutely critical. And it's a great idea to get familiar with not just these time complexities here, but all of the main array methods, time complexities, and also the space complexities. Because in your everyday coding, that awareness of the space-time complexities is going to help you write much more efficient code. And this is especially true if you're doing Leet Code questions or have an upcoming technical interview that you're preparing for. But you're going to need to know more data structures to be able to know when and when not to choose this. So now that we've explored how arrays work, I want to dive into some Leet Code questions and help practice some of the concepts that we learned, as well as learn about some of the algorithm problem-solving techniques, because there's a bunch of common techniques that you can use to solve these algorithms. So I've selected specific ones that are going to address different, it's going to give you the tools you need to solve a huger range of Leet Code questions, rather than just grinding thousands of Leet Code questions or hundreds of Leet Code questions. I've sort of selected around 50 that I want to go through that are sort of have the core techniques, So with that, then you'll be able to build on top of that with all this knowledge in data structures and choosing the right data structures and having those techniques. So you'll be able to solve, any of them, or at least the medium difficulty ones. So yes, if that was helpful, please subscribe to my YouTube channel, and I'll see you in the next video. Cheers.